Hi guys, this is Dionysian Mist, and today I'm going to be working on a project called Immutable Storage Solution (ISS). It's a blockchain-based storage solution, and it uses pieces, which is a small amount of data, to be put on the chain, and it's similar to IPFS. Except that it's actually kept on the chain, and it's stored through. I did do a video for this, but the recording wasn't recorded. So like I'll go like over what I discussed. So first, it works on the block lattice or blockchain. The pieces are about 256 kilobytes each, or there's 16 kilobyte ones for smaller pieces. It's encoded in base 58 and base 64, and each piece is hashed. I there's also blobs, which are a type of data storage, but it's stored by U16 or U8, which is an unsigned integer, 16, which is two bytes, and U8 is a byte. So that has to do with what we have up here: 255 for U8 and 65535 for U16. That's how many chains there will be. Then the basic idea is the consensus uses Blake 2 proof of work, uh, and what it does is it uses it nano style, which is U64 or 8 bytes, and it has to be past a certain threshold. And I'm trying to do it so it's dynamic, so it's different for each one, but like I may have to fix some things on that, and it's going to implement proof of history for timestamping. The hosting is done by host chains of U8 to U16, and it's sort pieces by U8 U16. So 00 to FF, or 0000 to FFFF. So that's about 65535 and entries. So time uses proof of history, which is consecutive hashing, and it uses hash maps to sort through the different addresses and blocks. I'm thinking about using the Raft protocol for consensus. Here's a pieces size: 256 to 256 kilobytes is a piece. 16 kilobytes is a mini piece, and 4 kilobytes is a tiny piece. The file system so has different file pieces that are split into different pieces, and I'm trying to make it more advanced. The pieces will like match certain patterns, kind of like how Git works, and like hopefully take up less space. And less pieces there are, the less file sizes. So like I'll have to find a way to do this, like you using a Merkle tree or something like that. A Merkle tree would look something like this, with the root being a hash and each one having a hash, and the leaf nodes being values. And CIDR storage is the rebuilding of the pieces. So it's a file that takes all the hashes and rebuilds them, kind of like a torrent. And it's GNU GPL. Should add v3. it works with different storage chains using the pivot namespace. Here's actually, let's get back into the chain. So here's the basic of the chain. One block contains about 16 transactions at max for 4 megabyte block. And the data is pieces, and they're hashed in Blake 3 with a nano style, and they're sorted by OX00 to OX01, OX02, all the way to OXFF. So like different people can host different ones, and I'm thinking of going up to 32 megabytes for a certain chain, but it should be pretty well done, pretty easy to get done, and routing helps you find the pieces quickly. Let's get into the environment. So the environment, there's a public facing ID. This ID is a U128, and it's to identify to all, and is unique and uses a namespace. You need to register your chain, and store it on the hash map by nodes to find the actual addresses, and it uses a CAD, which is a distributed hash table. And I think that's it for this. Let's go into the code. So this is where I left off with the code. This is not needed. Really the only thing I worked on right now was the blobs, which I have a pub constant, piece sizes in bytes, 266,144 bytes, and mini piece size in bytes, 16,384 bytes, and tiny piece size in bytes is 4,096. And here's the pieces. So I implemented SERD so they can be serialized. Here's the first implementation of it, and I just added the real like basics to it. So I'm still getting into that. For cryptography, it uses Blake 3 and Blake 2, and config an app I'm still working on, and this is a chain registration. But thank you guys for watching this. I'll get back to programming it soon. I'm sorry the last video didn't record.